Good evening. Tonight we welcome Ard Louis, Professor of Theoretical Physics at the University of Oxford, where he leads an interdisciplinary research group that investigates scientific problems on the border between disciplines such as chemistry, physics, and biology. He is also the Director of Technical Studies in Theoretical Physics. Ard Louis was born in the Netherlands and raised in Gabon, Central Africa, and received his first degree from the University of Utrecht and his PhD theoretical physics from the Cornell University. He was recently awarded the Institute of Physics South Edwards Medal and prize for pioneering the development of novel mathematical and numerical models that have contributed to our understanding of soft matter and biological physics at constant scale. In 2017, Ard appeared in the National Geographic Channel's The Story of God with Morgan Freeman, the episode of Proof of God, and Ard used an example from the world of mathematics to demonstrate his point that science and faith can coexist. So let's put our hands together and welcome Professor Ard Louis.
Thank you very much. Can you hear me okay?
Yes.
Great. I hear an echo, just I think it's gone. All right, so thank you very much for the invitation. It's a great pleasure to speak to anybody who loves science. I think science is the most amazing thing in the world. I can't believe I get paid money to work on this. My grandfather in the Netherlands had to leave school at 16 because to support his family, and worked in a factory his whole life, but always really wanted to be an academic and absolutely loved science. And I realized I'm very fortunate. I'm born in a generation where it was much easier to go to university and much easier to take a career in science. And so I sometimes pinch myself because I think I can't believe that I get paid money. And for some of you, that's your tax money. Thank you very much to let me think about science. So I think it's amazing. I love science, and it's always really wonderful to talk to people who also love science, even if it's not necessarily always what they're doing professionally. I think science is just a beautiful way of thinking about the world, and it's amazing we get paid money for it. And actually, this the story that I told Morgan Freeman in that documentary is probably the story of my very favorite equation. This is Paul Dirac, a great thinker in Cambridge, unfortunately not in Oxford, but in Cambridge, and one of the real greats of all time. And what you may remember is that in 1926, Erwin Schrödinger came up with this equation, which is the Schrödinger equation, which describes very small things like electrons. And actually, prior to that, almost over 20 years earlier in 1905, Albert Einstein came up with special relativity, which is the theory of very fast things. So here you see E is mc squared plus a momentum term, right? The square root of mc squared squared is just E is mc squared. This is an energy term. And Schrödinger's equation is also actually an energy equation, an equation for the energy of a wave function. So Paul Dirac asked a really simple question. What if something very small like an electron goes very fast, close to the speed of light, so that it must transform according to the laws of special relativity? And it turns out if you try to solve that problem, the only way that you can do it is by adding another object called a positron. So the electron has two components because it can be spin up or spin down. That was known. And so Dirac tried to write this down. And the only mathematical way you can write it down is not in 2 by 2 matrices, but in 4 by 4 matrices. And therefore not in vectors of length 2, but vectors of length 4. And so Dirac, being a great mathematical physicist, just said, well, that must be how it is, and wrote it down. And the amazing thing is that that other object that he just put into his equations was discovered a few years later by Carl Anderson at Caltech. It's the positron. So basically, Paul Dirac, simply by thinking about very small things and very fast things, showed the only mathematical possible solution to this was another kind of matter, antimatter, something so fantastical that it'd be almost impossible to imagine. And so, as you probably know, this electron has this antimatter component, which is the positron. The proton has the antiproton, the neutron has the antineutron, and every single particle has this antimatter equivalent. And when an electron and a positron, which are two bits of matter with mass m, come together, they will annihilate into energy E. So the E is mc squared is in there, right? The E from the positron and the electron will come together and send antimatter. If you go to a hospital and get a PET scan, positron emission tomography, what actually happens is they shoot positrons at your body. When these positrons hit an electron, they shoot off energy, and then you can use that to image. So this idea is not only an abstract, crazy idea about something very fantastical about the world, but it's actually used in technology today. So when physicists think about this, we think it's unbelievable. We think it's beautiful. When I was a student in the Netherlands in Utrecht, and I first learned about Dirac's equation in a course on advanced quantum mechanics, I just thought this can't possibly be true. It can't be true that just thinking about two very disparate things, the physics of very small things, the very physically very fast things, derived under completely different conditions, putting it together, that the only mathematically consistent way of doing this is to have antimatter. And of course, with the hubris of youth, I assumed that there must be something wrong and spent a whole night trying to prove Dirac wrong. Only to, at the end of the night, I realized I was not going to get anywhere and had to bow to the great master. And I remember walking around the city of Utrecht in a kind of daze while people were, getting up and cycling to work or getting a breakfast croissant. And I wanted to grab them and say, did you know that if you take quantum mechanics and special relativity, it inextricably means that there is going to be antimatter? I didn't do that. You can imagine an unshaven random undergraduate grabbing you in the morning and saying that. You'd probably call them in white. But it is something extraordinary. And I think it's beautiful. The Nobel Prize winner Eugene Wigner talks about the unreasonable effectiveness of mathematics, a wonderful gift which you neither understand nor deserve, which is a famous article he wrote in the 1960s. I think it's more than just beautiful. I think it gives a sense of the sublime, the sense of touching something that's larger than ourselves, something utterly and unbelievably beautiful. Over the years, I've worked on a lot of different things. More recently, I've actually done a lot of work on theories of evolution. I'm very interested in how evolution works. And um, one discovery I'm very proud of is and what I'm showing here. It actually got written up in the New York Times just quite recently. And what we basically show is that the same mathematical principles that happen in very abstract mathematics can be applied to the way that sequences map to structures in proteins, which are the little cells, the workhorses of your cell. Many of them are in complexes like this complex you see right here. And these complexes are typically symmetric. And we basically show that this preference for symmetry emerges naturally from the mathematical structure of the world. And when I first really understood this, I had the same kind of emotional experience as I had when I first understood Dirac's proof or prediction of antimatter. I just felt like I touched something which is larger than myself, something which is beautiful, but also sublime. Something, sublime is the kind of sense you have when you reach the peak of a mountain, you look down, you see the valley below, or when you're at the sea and there's an enormous storm and you feel the power of something larger than yourself, even if it's beautiful, even if it's attractive. It's something that points us beyond ourselves. And I think science has a way of doing that. Very clearly, astronomy does. You look out at the universe around you, there's something bigger than ourselves, something more beautiful. And this is naturally, it's something that's easier to see perhaps than the theories of Dirac, or maybe even easier to see than these evolutionary arguments. But there's a lot of beauty in nature. Um, and of course, this makes us think about, can science one day explain everything? So this is a picture of 5 megabytes of data in punch cards back in 1966. So it's about 60 years ago. That's the amount of storage you would need to store one image of the kind I take many of a day on my phone. And so for sure, there's been an unbelievable progress in science and in technology. And it's natural to think that this incredible progress, which is unparalleled in any other domain of human um, endeavor, should spread to all the big questions, the questions that really matter, the questions um, that like, what does it mean to live a good life, or what is good actually, and what is evil, and who is right and who is wrong, in all kinds of complex situations. Do you think if we could just use the scientific method that's been successful in technology that's prolonged our lives and made us healthier and wealthier, um, one also somehow make us happier if we figure out what the good life is? And so I think that won't work, unfortunately. And the reason it won't work, although it's a very pervasive idea in our public world, in schools, in journalism, and even in politics sometimes. I think it's because there are actually zombie myths around that that make this idea stay very much alive. So I'm going to talk about those zombie myths. Where zombies are things that you think you chop down, they keep coming back. And the first one is the main zombie myth I'll discuss today, although if I have time, I'll discuss a few more, which is the idea that science is the best avenue to truth about ultimate questions, which is the point I just made to you. So surely if we can split the atom, if we can uncover the structure of DNA, if we can decode the human genome, if we can work out artificial intelligence, this is going to give us ultimate truth about big questions. And here's my colleague Peter Atkins, for some reason his name didn't come up, but this is Peter Atkins, very famous physical chemist in Oxford, who said this: there is no reason to expect that science cannot deal with any aspect of existence. Although poets may aspire to understanding, their talents are more akin to entertaining self-deception. Philosophers, too, I'm afraid, have contributed to the understanding of the universe little more than poets. I long for immortality, but I know that my only hope of achieving it is through science and medicine, and not through sentiment and its subsets, art and theology. This might be a slightly extreme statement. But Peter is a more interesting person than just this, but he has he's basically believes in science. He thinks science is the only way that we're going to achieve real truth, and he wants to kind of downplay other fields of inquiry as being secondary. I made a documentary a few years ago with my friend David Malone. David is an atheist and a filmmaker, and I'm a scientist and I'm a Christian believer. So part of our shtick was we went around and interviewed people, and one of the people that we interviewed there, someone like this Peter Atkins. So if you want to hear more Peter, you can see that we interviewed him at his home and had a really enjoyable time. And part of our shtick was that, there's an artist atheist and a scientist believer. We inverted kind of popular stereotypes, although in fact, statistically, scientists are probably considered more likely to be Christians than artists are. All right, and so these are some of the things we looked at. Among others, one of the things we looked at was beauty and truth and the sublime. And so you'll see that's why I'm interested in these kinds of things. So if you like these kinds of big questions, these kind of big topics, how does science point you to big topics? If you go on this website, you can see a lot of our clips. And somewhere on YouTube, there are still some bootleg versions of the documentary publicly accessible. I can't tell you what they are leaked technically, but you can just find them by Googling. So here's one of my favorite people we interviewed. This is Alex Rosenberg. Alex is a philosopher, and so more careful in his thinking about scientism than maybe Peter Atkins, who is a scientist and a philosopher. So Alex also basically did the same thing. So let's see if I can get this to work. This is an interview we did with him about scientism. One second. I think what I need to do. One second. I'm going to. Apologies for that. For 1 second, I see this in the chat. I'm just one second. I was using my headphones and realizing that's probably not going to. So let me get the audio out, not into. There we go. Right. Now you should be able to hear this. So I'll start again. I say that. Nope. Audio. 1 second. Sorry, I'm having a little issue with my headphones that seem to be. Let me turn them off and turn this back on. So I'm just going to try and make sure this actually plays over the there we go.
Right, we can hear that.
Yeah, you could not hear that, yes? You could
Yes,
not
you
hear
could
it.
hear that.
Ultimate
Can you
intrinsic.
hear it now?
value,
Yes.
then the answer is there's no such thing as ultimate intrinsic value. And so either the question is ill-posed or the answer is no.
So I think where Alex and I,
Okay, 1 second. Apologies for this. Normally it's worked right out of the box, but I was trying to be quiet here and bringing it into my headphones there. Continue to share. There we go.
what is the value of a human being?
If you're using the word value to mean some ultimate
Right. Let's just need to get this to work.
And maybe that's the way we're evolved.
Now,
Then maybe
I'm apologies for this. I'm having a trouble with this thing. I'll stop it. But I have a backup plan, don't worry. Which is this one. So and apologies for this. 1 second. I'll get this working in just a minute. 340. There we go. I'll share this part of my screen. Man. Oh, technology. Now I'll make it full screen, and this should work.
says there are no deeper explanations than those that's correct.
Okay.
That's what scientism says. There are no deeper explanations than those that science provides. And science provides explanations for a broad range of questions that many people might look to philosophy or to religion for answers to. As science pushes back its frontiers, of course, the bigger the frontier, the more unknowns there are. But in some respect, we begin to be able to answer questions that had long been held as the privileged domain of philosophy.
so what are some of these questions that you think people say, we must look to other things for, which now you think science can?
Oh, well, consider the list after, does God exist? Questions about, does the universe have a meaning? What's the purpose of life? What's the nature of right and wrong? How does the brain relate to the mind? Do we have free will? What does moral responsibility consist in? That's a whole list of questions that constitutes the lion's share of philosophy. And I think all of them have answers that are given by science. So is there a God? Of course not. What is the meaning of the universe? It doesn't have any. What is the purpose of life? Ditto. Is there a difference between right and wrong, good and bad? There's not a moral difference between them. What is the nature of the relationship between the mind and the brain? They're identical. The mind is the brain. Is there free will? Not a chance. Does the lessons of the past have any particular bearing that would help us cope with the future? Less and less if it ever had any at all. So that's a nice list.
All right, so to go back to my PowerPoint, so the reason I like Alex, and we really enjoyed our interaction with him. You can find that on our website.
What is the
website as well? What I liked about Alex is that he's clear, and what you'll see in our Why Are We Here film is that David has the same premises as Alex, which is that there's nothing but atoms and molecules, but has a very different set of conclusions that follow from that. Whereas I disagree with Alex's premises but I do think that his logic is correct. In other words, I think if you do believe there's nothing atoms and molecules, then you're inevitably pushed into this kind of nihilism, that a whole series of things that we hold to be true and valuable break down. I think about them not enough. And I think that's the kind of the nub of the difficulty of the argument that science can answer all questions, which underlying it is the idea that there is nothing except atoms and molecules. And I think this kind of scientism, the idea that science can answer all questions, is endemic, particularly in science popularization. So here's a philosopher at the University of the Free University of Amsterdam, Jeroen de Ridder, who says, if one is to believe recent popular scientific accounts of developments in physics, biology, neuroscience, and cognitive science, Most of the perennial philosophical questions have been wrestled from the hands of philosophers by now, only to be resolved or sometimes dissolved by contemporary science. That's essentially what Alex Rosenberg was saying, is that, science has either resolved or dissolved these questions. So questions of, a lot of moral questions can be dissolved. A lot of questions of meaning, purpose can be dissolved, as opposed to just, or they're not even resolved, they're just dissolved. And that is a very common in popularizing. And I think what's interesting is that so much of popularization has this angle to it. And I'll pick one example. This is Stephen Hawking, the late Stephen Hawking. How can we understand the world? This is from his book, The Grand Design. How can we understand the world in which we find ourselves? Did the universe need a creator? Why is something rather than nothing? Why do we exist? These are all kind of philosophical questions. Traditionally, these are questions for philosophy, but philosophy is dead. Scientists have become the bearers of the torch of discovery in our quest for knowledge. In other words, Hawking is kind of saying the same thing. Here is Lawrence Krauss, who is a popularizer as well, and a cosmologist, who wrote a book called Universe from Nothing. Now, if you look very carefully at what Krauss is talking about there, he's making he has an interesting kind of scientific conjecture. It's really a conjecture, which is that just like I told you what the Dirac equation, which explains how electrons and positrons can come together and form energy. So electron, positron, they annihilate into energy. You can have the inverse as well, which is an energy that's in the vacuum of the universe can spontaneously form two particles, electron, positron pairs. And this is happening all the time, all around us. And Krauss said, well, what if a universe popped out of a similar kind of quantum vacuum fluctuation? And what's kind of interesting is that if you look at the book, there's a footnote somewhere saying, well, this is really a scientific question, but I'm going to ignore the philosophy because it's boring. And in fact, Richard Dawkins, my colleague, has it on the back. Even the last remaining trump card of the theologian, why is there something rather nothing, shrivels up before your eyes as you read these pages. And that's the something rather nothing question is a very famous one in philosophy. Why? It's kind of the ontological question. Why is there something rather than nothing? And Krauss claims to have solved it here. And when he got some pushback from, he also wrote this: philosophy is a field that unfortunately reminds me of the old Woody Allen joke: those who can't do teach, and those who can't teach Jim. And so philosophy in his mind has not explained anything. Now, what's kind of interesting about this is that a philosopher did respond to him, which is David Albert, who's a philosopher of physics, a very distinguished one, who wrote a very interesting and review of this book in the New York Times, which is he basically tells Krauss that he doesn't know what he's talking about, and then Krauss writes this thing, and it makes this, Albert is moronic. So what was Albert basically saying in his review? It's kind of an obvious point. Albert was pointing out is that the question of why something about nothing is not a question of where did the universe come from if we have the laws of physics, but it's a much more profound question, which is where did the laws of physics come from in the first place? And so, if you ask that question, it's a long question. I'll give you one quick way of running it, right? So why are there laws of physics that allow universes to emerge, assuming that Krauss's argument is correct? Well, one way that could be is that there were a previous set of laws of physics that preceded the current laws of physics and caused them, and that those were caused by another set of laws of physics before that. But you have to keep going back. So you could have one possibility, you have an infinite set of these causes but that would be possible, but it's not really a scientific conjecture because we don't know anything about infinite causes. It's not something that we have in science, it's really a philosophical conjecture. The other option would be to say, well, these laws of physics, and not just laws of physics, but say the laws of logic and the laws of mathematics, popped into being from true nothingness. So not just from a quantum vacuum, which is a hugely structured state, but just from nothing. It's also possible, but again, extremely odd or strange. And the typical theist argument would be to say, well, the reason that the universe exists is because there exists a necessary being, a being who cannot not exist, who willed it into creation, for example. that's perhaps equally strange, right? But all three of those are philosophical arguments. And the reason why Albert wrote such an incredibly strongly negative review, it's actually kind of fun to read just for watching what happens when a very smart academic gets angry, is that he just points out that Krauss has completely missed the basic elementary undergraduate point of what the argument of why something read nothing is about, as did Richard Dawkins in his description in the back. And I think Albert is a bit more upset because he thinks, well, surely Krauss should know better than this. And I think that's a common complaint that we might have about a lot of popularization. And so, just as Richard Dawkins, Richard Dawkins is a very good popularizer of science, but he's over the last few decades, maybe last decade or so, a bit longer, he's been very popularizing certain forms of atheism. And his argument was really, science is the ultimate way of achieving knowledge about the world. That, if you're a philosopher, is called epistemology. And so this is from a famous debate in the Sheldonian Theatre with Rowan Williams, and it was moderated by Sir Anthony Kenny, who's a famous philosopher. And at some point, Kenny says to Dawkins, your point about science being the only way of achieving truth about the world is really about epistemology. And Dawkins says, I don't know the words epistemic, and so I'm not going to use that. Which again is odd, right? Because it's basically what he does. And these are pretext. By the way, there's a very nice, a much better new video between Dawkins and Rowan Williams that just came out on YouTube, if you type it in, where they do a much better job of interacting with each other than this one. But the interesting point is that what you're having here is scientists who are effectively talking about philosophical questions. And not only are they getting it wrong, but they're reveling in the fact that they get it wrong and ignoring even the very, very basics. And that is odd. But I think that comes, but it's endemic. And it comes from, I think, a number of complex sociological and psychological factors, which I won't go into today. So I'm going to contrast those statements that I just put up there with another great atheist thinker, Sir Peter Medawar, who's also an Oxford Nobel Prize winner. And just before he passed away, he wrote his last book called The Limits of Science. And he says, science is a great and glorious enterprise, the most successful, I argue, that beings have ever engaged in. To reproach it for its inability to answer all the questions we would like to put to it is no more sensible than to reproach a railway locomotive for not flying, or in general not performing any other operation for which it was not designed. So what did he mean by this? He said that there is indeed a limit upon science is made very likely by the existence of questions that science cannot answer, that no conceivable advance of science would empower it to answer. These are the questions that children ask, the ultimate questions of Karl Popper. Karl Popper is a philosopher. I have in mind questions as, how did everything begin? What are we all here for? What's the point of living? These are somewhat similar questions to the ones that Hawking wrote down in his book, for example. It is not to science, therefore, but to metaphysics, imaginative literature, or religion that we must turn for answers to questions having to do with first and last things. And the book is basically a longer discussion of why this is true. So now you're seeing a very different argument by somebody who himself was not a believer of any kind in religion, but nevertheless did point out that science doesn't answer, and not only does it not answer, but no advance of science would answer those questions. So let me give you an example of rather than trying to talk about this in the abstract, let me give you a practical example. Let's say we want to decide what the value of a human being is. I've got a bunch of human pictures here on the screen. So humans are very diverse. And it's still never as very important that we have some sense of what their value is. And a lot of our modern Western society, particularly our political systems, our legal systems, our social systems, are built on the idea that humans have intrinsic value, that their value is not derived from external characteristics such as their gender or their race or economic characteristics like their wealth or other characteristics like their background, but that human beings have intrinsic value that's intrinsic to them. Human rights are one example of trying to codify some of that. When I was a scientist, how would I establish this idea that human beings have intrinsic value? Well, I want to be facetious. If I was a chemist, what would I do? Well, I can measure the value of the elements in each of these different people, but surely somebody with gold fillings is not worth more than somebody without gold fillings. For a physiologist, I could measure the size of your brain, or a psychologist, how smart you are, an anthropologist, how the community values you, or an economist, how much economic value you produce. I sometimes worry that our political overlords care mainly about that. But we all sense that these are impoverished ways of looking at the value of human beings. And we might go one step further in saying that trying to measure the value of human beings in these kinds of ways is not only wrong, but even dangerous. Because it will undercut some of the basic values upon which we've built our modern societies. And so where does the value of a human being come from? Well, it can come from many things. I told you about my grandfather in the Netherlands. So my grandparents were very staunch humanists. So humanists don't believe in any kind of religious beings, but they do believe in the intrinsic value of human beings. And so when I would sometimes talk to him and say, well, on what basis do you ground your the value of the intrinsic value of human beings? He would say, well, that's not something you need to ground. It's just a brute fact about the world. It's just true. And I think it's a perfectly respectable approach. You just say, it's just true. I don't need to ground it. Historically, this has been very much grounded in Christian values. In the West, particularly, it's grounded in the idea that if there is a God who created and loves us, and human beings' value derives from that relationship rather than from their intrinsic value. And this would be my own view, but I realize it's not the only way you can ground this. The point is, however you ground it, whether you ground it by saying it's a brute fact, or you ground it in religious values, or you ground it in some other values, science is not the right way of thinking about that. And that doesn't mean that you've got to retreat into irrationality. It just tells you that science can't answer this very basic question. And I can think of a very large number of other questions of this type which science cannot answer. That's not to say that science can't illuminate those questions. It for sure can illuminate those questions. So if we ask ourselves, what does it mean that we think human beings have equal value? We might have all kinds of consequences that means. And it might mean that, a good sociologist can go in a community and measure that something is treating some people worse than others. That science is telling us that. If we then have the value that this is wrong rather than right, that we think that everybody should have be treated equally, if we believe that's a true value that is actually, it's a fairly rare value historically for people to have, but if you do have that, which we now have in modern West, then that scientific research helps us to implement that in a much better and smarter way. So science that's one simple of many examples in which science helps illuminate the questions, but doesn't answer the question of why do we think that human beings have intrinsic value, or why do we think that human beings should be treated fairly, for example. So in the end of the day, we're all philosophers and theologians, and science has little to say about many important questions. And I really can't think of any advance of science, no matter how amazing it would be, that would allow us to answer those questions, because science just it's doing a different kind of thing. It's trying to measure things, it's trying for patterns, natural world, but it's not really answering any of these ultimate questions. Here's a little cartoon, simple but wrong is where the masses go. Complex but right is where hopefully the people are, a smaller fraction of people go.
Ard, can I
Yes.
just be there for a moment?
Yeah.
We don't seem to be able to see your presentation anymore.
Oh,
It
just now.
disappeared to your video.
It disappeared
And,
when? When did it disappear? Just now?
no, it disappeared after your video
Oh gosh.
clip
Okay,
stopped.
let me try again. One more try. Here we go. Can you see it now?
I can see your editing screen.
Okay. Sorry about that. That's been quite a while. And how about now?
Right, okay, we can see it now.
Okay.
Okay.
So did you not see any of this stuff, right?
No.
Oh God.
We thought
well, there you go.
we were just
There you can see that.
freewheeling it.
Yeah. This one. Okay.
Just
I'm sorry.
about there.
There, yes. Right. But but you heard me anyway. Right?
Yes, we heard you. That's fine.
Okay. All right.
Okay.
All right. Sorry about that. Thank you for letting me know. I thought it looked like it was sharing on my screen, but it apparently wasn't.
Okay.
Right. So anyway, now for sure you need to look at it because I'm giving you a cartoon and there's no use me talking about a cartoon. So the point would be, ultimate questions are difficult to answer, and but that doesn't mean that we shouldn't try. So that's the main kind of point I want to make in my talk, but I'm going to jump on a few related questions just because my experience tells me that people often have a series of other kind of zombie myths that are linked to this question. And my hypothesis is that some of these other zombie links that kind of help support or create the structure that allows people like Krauss or Hawking or Dawkins and others to say these rather ridiculous things. And one is the idea that scientists somehow don't believe in God, or if they do, they're like vegetarian butchers, right? They're people who try to sell something that they don't really believe in. And it turns out that, empirically, that's not true. So here in University of Oxford, we have quite a large group of Christian academics that come together, and it's always the scientists that are there in the largest numbers. Um, if you really want to understand this in detail, my friend Elaine Eklund, who's a sociologist, is the world leading thinker on this, and has written a good book where she studied what scientists. She basically did a giant study of scientists in 8 different countries. And embarrassingly, what you find is that the fraction of scientists who are believers is largely correlated to the fraction of believers in each of these countries. And so science itself doesn't seem to have the same impact on people's belief as you might think. The other kind of zombie myth that's often portrayed that goes a bit like this. There's a conflict metaphor for the history of science and religion. And the conflict metaphor works a little bit like this. Science and religion were typically at each other's throats until finally, science was able to untangle itself from the oppressive power of religious people and become free and give knowledge to us. And so part of the idea is that by following science, you're on the right side of history. You're against superstition and the Dark Ages and this kind of stuff, and you're in favor of knowledge and in favor of free thinking and in favor of basically rationality. And who wouldn't want to be on that side? But unfortunately, or for people that believe that historical metaphor is probably the wrong way of thinking about the history of science and religion. So I have here Peter Harrison, who was he's a very famous historian of science, who was professor at Oxford, who's now gone back to his home country in Australia, in Queensland. And in a very famous book, he writes, "Those who argue for the incompatibility of science and religion will draw little comfort from history. The myth of a perennial conflict between science and religion is one to which no historian of science would subscribe." And in fact, there's a book, an edited volume here with about 20 historians of science who write a book called Galileo Goes to Jail and Other Myths About Science and Religion. It's edited by Ronald Numbers, who was, and basically all the historians of science are complaining about the conflict myth, which they see as just the wrong way of thinking about the history of science and religion. And in fact, Alan Chapman, whom you may have had speak at some point, because he passed away just a few weeks ago, sadly. Alan was a very famous historian of astronomy here in Oxford, who wrote Slaying the Dragon, Destroying the Myths in the History of Science and Faith, by which he meant the conflict myth to a large extent. Now, that's not to say that science and religion were always, things were easy. Sometimes things were complex. Sometimes the religious belief, particularly Christian religious belief, had a very strong positive impact, sometimes negative impact, sometimes a neutral impact. But for sure, the conflict myth is just the wrong way of thinking about it. I won't go into much detail for that. Just if you want to read it, read Galileo Goes to Jail or Alan Chapman's book as a quick sense of the much more interesting, much richer connection between science and faith. Another kind of zombie myth that I think is playing in the background here is that believing in God needs some kind of special pleading. It's like believing in a pink unicorn, it's Bertrand Russell's, this is Richard Dawkins' version, or a flying teapot, which is Bertrand Russell's argument. I don't need, well, here's Richard Dawkins. If you want to believe in teapots, unicorns, or tooth fairies, Thor or Yahweh, the onus is on you to say why you believe in it. The onus is not on the rest of us to say why we do not. We who are atheists are also a fairist, a teapotist, and a unicornist, but we don't have to bother saying so. So the kind of idea there is basically that the default option is to not believe in God, and that if you want to believe in God, you've got to give me evidence for it. In the same way that if I tell you there's a pink unicorn in my garden, or there's a flying teapot that's hiding behind the moon, the onus is on me to give you the evidence for it. Now, to some extent, this is true for amazing things. So if I tell you that in my lab I've just discovered this unbelievable new virus, the correct response from you within the community is skepticism and saying, well, I won't believe it, I won't publish it until we see some, very strong evidence for it. And the grander, the bigger the claim, extraordinary claims need extraordinary evidence. So that's basically how we do think about grand claims. And so that the instinct is that this should also be true for things like gods. But I think that this is the incorrect way of thinking about it. And so I've already given you this argument for why the laws of nature, right? And the laws of nature have always existed. The laws of nature probably to being out of ontological nothingness, or the whole space time is dependent on non-spatial temporality, necessary being. And the reason I ran that argument is, and you'll see it in a minute, is that it tells you that these big ultimate questions about gods can't really be reduced to this kind of way of thinking. That's because the God that Christians believe in, for example, is not a being like ourselves, only bigger and stronger, that lives out there, but the God is the reason for why the universe exists. In other words, the whole of the universe is dependent on God in a way that is critical. In other words, if God were to stop sustaining the world, it's not like the world slowly grind to a halt, it would literally stop existing. And so this is a very famous Cambridge physicist, Sir John Polkinghorne, who wrote, if we are to understand the nature of reality, we have only two possible starting points, either the brute fact of a physical world or the brute fact of a divine will and purpose behind that physical world. So my previous little set of why is there something rather than nothing ideas, the first two are kind of the kinds of options that you would have that you had as a brute fact. There was nothing but the laws of nature. And the third one is the brute fact of there being some kind of divine will and purpose behind the physical world. And then the question is, if I have these two starting points, okay, which I'll have an obvious way of knowing which of the two is true, then how does evidence interact with that? And there I move to Bayes' theorem, which you probably remember hopefully from your schooling. So the probability that theism is true, given evidence, right, is the probability that theism is true on its own times the likelihood on theism for that evidence. And the same ways what I can do is I can say, well, if I have some evidence, how likely is atheism given that evidence? This is the way I was thinking about it. It's the probability, the a priori probability of atheism times the likelihood of atheism generating that particular evidence. And what in fields of inference, for example, people often talk about the rate. If you want to say what's going to be more on some evidence, what's going to be more likely, theism or atheism, which is what you're trying to solve, you may not know very well what the a priori probabilities are, but you can look at the Bayes factor, which is the ratio of their evidences, or sort of ratio of their likelihoods, pardon me. And so what do I mean by Bayes factor being larger than one? Well, there are things about the universe that are really remarkable that are more likely on theism, which is what the likelihood is telling you, than they are on atheism. So the fact is that in order to do science, we need to believe that nature is uniform. In other words, if I do an experiment here in Oxford, somebody in Cambridge, if they're smart, should get the same results under the same set of conditions. That's not obvious that would be true. We believe it's true because it works really well in science. But for most of history, people's experience of nature is that nature is capricious and unpredictable. And so historically, the idea that the universe is uniform or the universe is even intelligible has deep theological roots, because if there's a God behind the universe is more likely to be uniform, and perhaps if there's intelligence behind the universe, it might be intelligible. But even ignoring that historical evidence, you can just ask yourself, is the evidence that the universe seems to be uniform and seems to be intelligible, is that more likely given theism or more likely given atheism? And it's for sure more likely given theism, because if there's nothing that has molecules, why would that create a uniform set of natural laws? You can imagine non-uniform universes really easily. Why would it be intelligible? It's very surprising that it's intelligible. It's not necessarily evidence. It's on atheism that might be more surprising. But on theism, it's more likely. And I can go through this. I can look at moral realism. That's the idea that there are moral facts about the world. So, for example, torturing children for pleasure is wrong, regardless of whether I believe in it or not. That would be if I believe that's true, irrespective of people's cultural backgrounds, I might think that's a moral realism. If I believe moralism is true, it's much more likely to be true on atheism than is on so much true on theism than on atheism, etc. There are also things where the base factors the other way around. So the suffering we see in the world seems to be much more consistent with a world that's just random, right? So a world where there are a world on theism, it's more surprising that there is a suffering or the amount of suffering that we see than there's an atheism. So that's one of the base factors the other way around. The reason I point this out is that the right way of thinking about these grand questions about whether there's a God or not, is really in this kind of a form, where you take one of these two starting points, then look at the world and ask yourself, which of the two does it make more sense of? The naive way of thinking about it, which was expressed in this pink unicorn or flying teapot way, it makes the fallacy that the kind of God you're looking at is an object that's already in the universe, rather than the God for whom for whom the universe, who created the universe and who sustains it. So that's where that error came in. Another kind of I like Richard Dawkins because he's a great rhetorician. So this is another one of his great quotes. I call this a zombie myth 5, false binaries. So faith is a great cop-out, the great excuse to evade the need to think and evaluate evidence. Faith is belief in spite of, or even because of, the lack of evidence. Now, sometimes people's faith can be this way. They can believe in things in spite of evidence, for example, and that is indeed an incorrect way of thinking about things. So he's right about that. But the question is that the only kind of thing that we mean when we talk about faith? And I want to give you an example from a friend of mine at Stanford, Bill Newsom. So Bill was walking across the Stanford campus one day with one of his colleagues, and his colleague looked at this building, which is the Stanford Chapel, and he said, we should blow this thing up, okay? Because this chapel is a monument to irrationality. And to which Bill responded, well, in that case, we should blow up my house, because my house is also a monument to irrationality. And the friend took a step back and asked, well, why is that? Well, so Bill said, look, if I want to use science, and his friend was a scientist, to try to adjudicate all the important questions of life, then, or the scientific method to do that, then there are many things that I've decided to do that I really couldn't have decided on the basis of science. So, in science, what you try to do is you try to get evidence for something, and once you get enough evidence for it, then you believe that it's true. But let's take the example of marriage choice. You want to choose a partner. The fact is, there are irrational ways of doing it, which is to grab the first, the best person that you see and say, would you marry me? That would be an irrational thing to do. So what we do instead, so for example, when I got married to my wife, I got to know her. We did these we spent a lot of time around each other to see whether we were compatible. We spent time with people that we trusted and asked them for their opinion. We even did those little questionnaires, where how do you squeeze your toothpaste and all that kind of stuff. But you don't really marry somebody because you will score 95% on these questionnaires. There's something more there. And the reason the more there is basically that you don't really know what it's going to be like to be married to somebody until after you have been married. And the reason for that is that that evidence is not accessible to you until after you've taken a step of faith. If you sit around and wait until you have incontrovertible evidence for sure that the person that is just going to be the right person for you to marry to, then that person will be long gone. And so Bill pointed out that many of the most important things in our life have this kind of character where you have to take a step of faith. You have to make a step, and that evidence will only become accessible to you later. So this is basically just a false binary. And the last zombie fallacy I want to talk about is a kind of God of the gaps fallacy. So this is a cartoon that I like, some equations, then a miracle occurs and the equations keep going. And the person says, you should be more explicit here in step 2. But, religious people often make this error. They basically say, look, if we explain something scientifically, then we've explained it away. And therefore, they would like there to be some mystery at some point where, some miracle occurs. And you can do an atheistic version of that as well, which basically says once we've closed some explanatory step, then we've kicked God out of the story. And Christian theologians have long argued this is incorrect. And this is Charles Coulson, Oxford's first professor of theoretical chemistry, who said this, which is called the gaps, is a fatal step to take. For it's assert that you can plant some sort of hedge in the country of the mind to mark a boundary where transfer of authority takes place. Either God is in the whole of nature with no gaps, or he's not there at all. And the point of this is that basically the reason why people fall into the God of the gaps fallacies is because they somehow assume that by explaining the scientific explanation of something, that we've explained everything away. And I often use this illustration from John Polkinghorne, in fact, to try to explain why that doesn't work. So let's say that you come to my house and I've got a kettle boiling on the stove, and you ask me, why is the kettle boiling? I said, well, the kettle's boiling because there's a heat source that transfers thermal energy across the container wall into the liquid. That increases the mean square velocity of the water molecules. When that mean square velocity, which is directly proportional to temperature, reaches 100 degrees Celsius, there's a phase transition from a condensed phase to an expanded phase, which we call boiling, and that's why the water is boiling. Or you could come to me and say, why is the water boiling? And I could say, I fancy a cup of tea. Would you like one? Now, the important point is that both of those answers are correct. They're just different levels of explanation, different ways of explaining the same process. And the reason why the God of the gaps doesn't work is because just because I've explained to you the gaplessly, hopefully, why the water is boiling in a scientific way doesn't mean that I've therefore explained it away. I've just given you one of several possible explanations for why this might be the case. So the upshot of my talk is really to say, as wonderful as science is, as much as I pinch myself that I get paid money, including perhaps your tax money, for which I'm very grateful, to work on these things that I find interesting, as much as I think that we should fund more science, we should popularize science more, we should do more science, I don't think that it can answer ultimate questions at all. It can illuminate them, but it definitely can't answer them. And in fact, thinking that it does so is dangerous, because I think it'll eventually erode away many of the things that we hold to be valuable if you try to go down that route. Science has very little to say about important ultimate questions, but we're all some kind of philosopher or theologian, and you in my audience now will all have some kind of theory of what it means to live a good life, some kind of theory about what's right and what's wrong that you picked up from somewhere. And the only question really is whether those theories that you have, that you need to have in order to live your life, are good theories or bad theories. So you can have rational and irrational ways of thinking about these. And although science can illuminate some of these questions, it can't, and no advance of science will be able to answer them. Right, thank you. That was my talk. I hope that was helpful for you. And I'll stop my share now and hand over to my hosts.
That we do know Alan Chapman. He was our president.
Okay.
And he'd been our president for at least 2 decades.
Okay.
So he will be very much missed.
Yeah.
We're going to move quickly on to questions and answers. Where are we going to start? I think what we need to do is probably take this part of the meeting down to the pub and do this over a couple of pints, but we can't do that. So I'm looking for questions online, a digital hand, please, in the room. Usual thing, just pat my attention, and we'll take over to you. Simon, do you want to? You looking? No, nobody's. Nobody seems. Oh, Tony Morris in the room. Let's just get a microphone to him.
Hi, there's plenty to think about there. Stephen Wolfram talks about nature being non-computable.
Yeah.
And nature hides its tracks. So could it be possible in Wolfram's world to scrub out nature and put thought in there?
Yeah, so yeah, so you're asking, so basically what can you hear me okay?
We can hear you, yes.
Okay, great, super. Yeah, so Stephen Wolfram is speaking about universal Turing machines. So universal computers can there are always things that are not computable by them. People don't realize that Turing, when he came up with the foundations of modern computer science, was doing so in order to show that there are things that computers can't calculate. This is linked to Gödel undecidability. I don't think myself that this idea tells you much about big philosophical questions of why are we here, or that it creates a lot of space for divine action. I mean, Roger Penrose here in Oxford thinks that something that, our brains are non-computable in that sense. Um, and it is very interesting, so that people don't realize that that there are things that computers can't calculate. So the way that that was originally done by Turing was by showing that there are programs that don't halt, and that there's no algorithm that will tell you whether a program will halt or not halt. So what it really is showing you is something about the difficulty of building up a framework of mathematics that purely from a set of axioms, that no matter what happens, there's always some things that are true that are outside the axioms. I don't think that I mean, what it's useful as to help us realize that some of the that just because you have a bunch of axioms, that there may be things that come out of it that are true but can't be proven by those axioms, tells us that getting to truth is much more complex than we might think. But not sure that it creates extra openness in the universe. I think a stronger maybe location for that could be in the kind of probabilistic nature of quantum mechanics. But again, there I think it's quite a controversial set of questions. But thanks for that. I think it's that Wolfram's popularized some of those ideas. He's probably a little bit on the extreme side of how important he thinks uncomputability is, but there's no question that there are uncomputable things in the physical world.
Can I just come back with a Roger Penrose question then?
Yes.
Yes.
Mhm.
So
Yeah.
Penrose spoke about microtubules in the brain probably 25 years ago, maybe a bit
Yeah.
more. And he got pilloried for it at the time from biologists. But I think there's been some recent work suggesting that the quantum effects of thought are probably more dominant in the brain than people think. Or certainly Penrose was proposing.
So Penrose and his collaborator Stuart Hameroff wrote about this. I would so that for sure there's been a lot of interest in what people call quantum biology. So trying to find quantum effects in biology. A very famous example would be photosynthesis, but there are also examples from actually one of my colleagues here, Peter Hoare, who's shown that the way that birds can follow north-south lines in their migrations may be through a quantum effect in their brains and a Moore-like effect. And so that is an example of a quantum effect in the brain.
Are you okay with the Penrose question, Tony?
Yeah.
Yeah. Okay.
Thank you.
I'm looking around for any other questions. Roy Gunston in the room.
It's not quite a question, it's more of a comment. I've just been finishing reading a book on Galileo, Guy Cosmolomango, if I can get his name right. And basically, I mean, a lot of the problem wasn't really the conflict between science and religion. It was the politics of the age that was actually causing the problems.
That's right. Yeah. So Galileo, that book is one of many books on Galileo that all basically show the same thing. A, Galileo was a bit of a difficult man, but B, there was a lot of politics going on. And so what did happen, of course, is that there were proxy battles about the politics that sometimes got scientists involved, which is what happened to Galileo. But in fact, the idea that Galileo was put in jail, first of all, was a myth. He was put under house arrest in a villa, and the idea that somehow the church thought that his ideas were anti-biblical is also way more complex, and probably not really the right way of thinking about it.
Okay, Roy. Just an observation there uh, about the Galileo incident.
I've just lost you again. I'm so sorry.
I'm just saying that if the church did make a mistake, then maybe the mistake was that something like 250 years before, they adopted the Aristotle's view of the
Yeah.
universe. And that came with controversy as well. So,
I mean, yeah. So just to say that, it's the Aristotelian view of the universe, which is the idea that the universe is the center in the earthly sphere, where you've got a straight line, rectilinear motion, and you've got the heavenly sphere with circular motion. So part of what Galileo was undermining by showing that there was circular motion around the planet Jupiter was that idea that everything moved in a circle around the Earth. So that was and heliocentrism and some Aristotelian ideas that were undermined there. Kepler was another person who talked about this. Luther, one of the greatest theologians of all time, calls Kepler that damn fool because everybody knows that Joshua commanded the sun to stand still and then it stood still, so therefore the sun must be orbiting around the earth, was his point. And so it's not the case that there wasn't conflict. But if you look more carefully, Luther's view was not the only view. There were other people at that same time who were Keplerians, or Copernicans. And we would look back now and say that the church got itself caught up in what's effectively a Greek set of ideas and needed to be freed from that. And that was part of the story as well. But also part of the story was just personalities and politics and complex things.
Yeah.
That's what makes it makes the whole story very interesting. I mean, I'm sure that you guys know a lot about this. If you had Alan as your chair.
okay, Henry, online.
Hello. Is
Hi.
it simplistic to ask if there is a God, the God should intervene? And where did he or she intervene?
So I'm sorry. So I missed the first part of the
The
question.
universe? Can
I
you
missed
hear
that.
me?
Can you say? I heard you, but you broke up a little bit. So something about God intervening, but I missed the first part. Could you repeat the question? I'm so sorry.
Is it simplistic to ask that if there is a God, the
Yes.
God would at some places intervene? And where would God intervene? At the creation of the universe, at the creation of life, or is there anywhere else he would need to intervene?
Well, so I think that's an extremely complex question, not a simple question. It's in the category of questions that are much more difficult than scientific questions. It may also be a very important question because the truth or non-truth of that question could potentially have a big impact on our lives. But for sure, it's a hard question to think about. So I'll give you one version of that, of why that might be interesting from what's kind of a Christian point of view. So one idea would be, would God intervene in the workings of the world, or do we have a kind of deist God who created the world and is then separate from it? And those are two options that could be possible if you believe there is a God. So you could believe there's a God who kind of created the world and then lets it run on its own and it's no longer interested in it, or you could believe there's a God who wants to interact with it. And then you could ask yourself, well, what would I look for to adjudicate between those two options? So the God who interacts with the world and the God who doesn't. And well, if God created the world and God is clearly a lot bigger and more complex, then we are probably far outside of our understanding. So I'll give you an illustration if that helps, that I think I found helpful when somebody first gave it to me. So in fact, I can tell you my own version of the story, which is when I was a PhD student, I lived with some other students in a shared home, and one of the students, a chemist, loved saltwater tropical fish. So he had a beautiful tank with these saltwater tropical fish, which he nicked. In fact, he nicked uh, measuring stuff from the chemistry department to make sure that the water had the exact right salinity and the right pH. because these fish are very sensitive to this. And not only that, they're also very expensive, and we didn't have a lot of money, so he took very good care of them. So we spent a lot of time and energy taking care of those fish. He also brought them different kinds of food and would feed them different kinds of food. But in spite of that, every time I came to the tank when it was my turn to feed, the fish would all cower away in these little holes. They were terrified. And one day I thought to myself, well, how on earth would I explain to these fish my love and care for them? And I realized perhaps the only way I would do that would be for myself to become a fish and speak the language of fish. So when you think about it that way, then if God is not a deist God, but a God who someone wants to interact with humans, um, something like the incarnation would be a place to look for. So you might want to look around and say, is there some point in history where something like this seems to have happened? It's a perfectly rational thing to do. Or you might look for some kind of text, like a Bible or something similar, where God might have communicated to us in human form things that God wanted us to know. If you were to assume that the Christian Bible is indeed somehow God's communication to us, then there's a lot written there about the way that God interacts with the world. And I think what it says is that, that God interacts with the human world. In other words, God normally sustains the world in the normal laws of nature, but occasionally steps in and does something unusual. The most famous example would be the resurrection of Jesus from the dead. And in those cases, God doesn't sustain the world in normal way, but in some unusual way. Those are usually done for God's redemptive purposes in mankind. So the questions that you asked, like, would God intervene at the origin of the universe or the origin of life, are harder questions to answer because the Bible doesn't directly give an answer to those. It suggests quite strongly that God created the universe at the beginning. Surely, even if God created the laws of nature, that allowed a universe to begin, but at which point did God intervene again at some point? Or was it that once the laws of nature were there, something in the universe was inevitable? These are all interesting questions that are hard to answer. If you're interested in this, I've written, if you type in Ard Louis miracles, you'll see a longer discussion of exactly this question of where does God interact or intervene in the world. But my point is, in this really short little sketch that I've just given you, which is very, very impoverished and short, is that these are actually not naive questions, but incredibly important and incredibly difficult questions about which we should think rationally and carefully.
Okay, Henry. No, Henry's
Okay.
okay. I think we've worked you hard enough, Ard, this evening. And if we've got no more questions, I'm going to ask everybody to join with me and give you a big Mexican Swinton Astronomical Society thank you. Thank you very much.
Thank you. Thank you. It was a great pleasure. Nice talking to you.